All right, section 4.1 is our next lesson, first lesson of our next unit, and we're going to solve systems of equations by graphing. You're probably wondering, what does systems mean? And it just means we have more than one equation and we're trying to find that solution. So in topic 1, we started by just solving equations with one variable, and that was x. We had things, like 4x equals 16. One equation, one variable. And we learned that we could solve these equations and we could have one solution, which is just where x equals a number. We could also have infinite solutions or no solutions, depending on how the equation solved. In topic 2, we saw equations in two variables, like y equals mx plus b, where we have our variables x and y, and we learned how to graph those equations. So now in this unit, topic 4, we're going to compare two equations, so more than one equation, and we're going to find their solutions, which, just like in topic 1, we can have one solution, infinite solutions, and no solutions. The only difference is our one solution isn't just x equals a number. Since we're dealing with equations that have two variables, our one solution is also going to have two variables written as an ordered pair, our x comma y. So our solution is actually going to be just one point on the line, some coordinate x comma y. We're going to learn several methods of how to find these solutions, and this section focuses on our first method, which is solving systems by graphing. So in order to graph these equations, we're going to use Desmos.com to visualize these graphs and discuss them. If you're on a computer, you can literally go to the website Desmos.com. If you are on a tablet or on a phone or anything, you can download the Desmos Graphing Calculator app. That's what I'll be using here on this iPad. So in our workbook, we're on page 143, we're going to look at example 1. It says solve a system of equations by graphing, and we can see that in 1a, it's going to give us two lines, y equals 1/2 x minus 2 and y equals 3x minus 7. What we are going to do is we are going to graph both of those equations and look at where they intersect. If we're going to solve a system, that means find where the two lines intersect when they touch. And our answer is going to be that intersection point, x comma y. So let's get started on this first thing. I'm going to switch to Desmos. You guys are watching in real time. We're going to type in both of those equations. So I do y equals, and then I'm going to do 1/2 x, 1/2. Let me arrow over, type in x, minus 2. And notice it graphs that line for us. Desmos is really nice and neat. Now I just graph the second line, and I do the same thing. Y equals 3x. Where's the 3? There it is, 3x minus 7. And now it has graphed both of those equations, and we can look at where do those points touch. Well, they intersect at this point right here, 2, -1. So if we're writing our solution, here's a screenshot of that intersection. They intersect at the point 2, -1. So my answer truly is just 2, -1, where 2 is my x value and -1 is my y. All right, so you guys try part B. Take a second, try graphing those two equations using Desmos. Just type it in and see what we get. Let's check it. If you graphed these and you did a -1/4 x plus 1, we intersected at the point -4, 2. So that would be our answer, -4, 2. All right, that's a perfect example of when we have just one solution. The lines intersect in just one point. Well, what about when we have none or infinite? Let's look at what those look like. So example 2 is all about systems of equations with infinitely many or no solution. And to find this, we're going to use the same process. We're going to take both of our lines and we are going to graph them using Desmos. So let's switch over to our Desmos. Let's get rid of these two equations. Let's graph the first one. We're going to type in everything we need, y equals, and we're going to do 1/2 x, so 1 divided by 2 with the x next to it, not in the denominator, plus 7, awesome. Second line is 4x minus 8y equals 12. So I can type that in exactly like I see it. As long as I make sure that the both things that I've typed in are what is in my problem, I'm good. Let's zoom out and let's look at these. What type of lines do you notice that these are? Those are parallel lines. Look, they keep going on and on and on. They never intersect. Well, we just learned that the solution is where the two lines intersect. So, hello, if we are not intersecting, do we have a solution? No, there's no solution. So if we are parallel lines that never intersect, we don't have any solutions to this system of equations. Remember, system just means more than one, a grouping. So here we've got two equations and they have no solution because they do not ever intersect. Okay, well, let's look at part B. Let's graph those. So I'm going to go back to my Desmos. I'm going to exit it out. I'm going to graph the first one, 3x plus 2y, so 3x plus 2y equals 9. All right, so that line is the black line. This line is going to be a different color. Let's see, it says 2/3 y. Well, I don't want that y in the denominator, so I need to arrow over. Okay, there we go. 2/3 y equals 3 minus x. Okay, we don't recognize this format, but notice that that showed up as a red line. But look, it's the same. It looks the same as the black one. These are the exact same line. They're just written in different formats. So when we graph something and it's actually the exact same line, let's think about what that means for its solutions. If the solutions are where the points touch, where they intersect, if they're the exact same line, they're always intersecting. These are two lines right on top of each other that are exactly the same. They are always intersecting. That is our infinite solutions. Our infinite solutions are when the lines are exactly the same. So this answer would be infinitely many solutions. These are two lines right on top of each other. That means that they are going to have the exact same points, the exact same solutions for all of eternity as they go in positive and negative directions towards infinity. So this is graphing systems of equations, and you will use Desmos.com to practice graphing both of these lines and seeing where they intersect.